Okay, I worked this problem a second ago and I didn't realize all we had to do is set up the integral. I was finding the area. Okay, in this problem we're going to, it says to write a definite integral that represents the area of the shaded region. And I have to ask some, give me some leeway here. This pen I'm using kind of gives me false marking, so I'm looking at what's already written and there's some extra lines that aren't supposed to be there. So I'm going to try to not let that happen. But here we go. The idea to do this is we want to look at the upper curve minus the lower curve. And we have two parts. We have the part that goes from -1 to 0. And we have the part that goes from 0 to 1. So in the first part, the upper curve is 3 times x cubed minus x. We're going to subtract from that the lower part, which is 0. And put our dx there. And then add to that. For the second part, the upper curve is 0. And our lower curve is 3 times x cubed minus x dx. And I need to put another parenthesis here. And another parenthesis here. I think I have too many parentheses there, but it still works. Okay, so what do we really have? Is we have the integral from -1 to 0 of 3 times x cubed minus x dx. And then we have the integral from 1 to 0 of -3 times x cubed minus x dx. Now if you notice, these are symmetrical curves. That is, 3 times x cubed minus x has a origin symmetry or point symmetry about the origin. And so the first part is basically the same as the second part. And so we could write this as either 2 times -1 to 0 of 3 times x cubed minus x dx, which would give us 6 times the integral from -1 to 0 of 3 times x cubed minus x dx. Or we could write this as 2 times integral from 0 to 1 of -3 times x cubed minus x dx, which would be -6 integral from 0 to 1 of x cubed minus x dx. This 3 shouldn't be there. Okay. And that's how you get those two possible answers. So it's either 6 times the integral from -1 to 0 of x cubed minus x dx, or -6 times the integral from 0 to 1 of x cubed minus x dx. I hope that explains it.